Today's meeting is on unlocking PyTorch with prompt engineering. This is part two. And today we'll create a FFN, feed-forward neural network, a CNN, convolutional neural network, and an RNN network. And with that, a recurrent neural network. And with that said, just a little bit about me. I've been around for a while. I'm an old guy, and I have a PMI ACP. I like that one because it's a Scrum Masters Plus type certification. I like running small teams. The great thing about running hackathons is you get to run these 3 to 5 member teams or just 2 or 3 days, and then you try to build something. So it's always a challenge and it's always fun. 23 cloud certifications. I am avid generative AI hacker, and just it takes some getting used to it and just throwing yourself into it over and over again, and eventually you get better at it. Got a bunch of degrees, and if you want to get a hold of me, I got a bunch of links here. I got my LinkedIn, my multi-cloud, my Hugging Face, my LabLab AI. I will paste all of those in the chat in a moment. Today's is learning PyTorch using prompt engineering, part two. And then next week, we'll be wrapping this up with part three. And then I'm moving on and going to do a whole series in Hugging Face on getting Hugging Face and tuning Hugging Face models. So it should be a lot of fun. Kind of similar thing, starting off from the basics and doing 10 projects that we can go through and learn together. I haven't posted part three yet on my cloud or on LinkedIn, so I'm going to do that after this meeting today. With that said, of course, AI is being embraced by the world. Over 50% of Fortune 500 companies are using it, and 150% increase in workflow. And I say, if that's all you're getting, it's not worth it, right? No, that's not a good number. Basically, Dentons, a worldwide, largest worldwide lawyer firm, as far as number of lawyers, uh, took one of their systems that was taking lawyers 4 hours to prep for a court. They put in a RAG database system, and now it only takes them 5 minutes. That's almost a 5,000% efficiency in work. And not only that, they didn't wear themselves out. Over the next 4 hours, they just popped it in and got their answers. So this type of stuff is extremely powerful. Well, not only is the way we use technology changing, the actual technology is changing. So, and there's this concept, world as a prompt, and Spatial Labs also has the concept as world as an SDK. That's pretty interesting. But I don't know if you've heard about the Copilot PC. Microsoft announced this at their Microsoft conference recently. But it has a CPU, a GPU, and an NPU, a neural processing unit. And what this buys you is that where you're trying to, you go up to the cloud to process your data, you can just do it all on your computer now, which is pretty nice. We are entering it. We've moved from generative AI, working with these models to what I call the year of devices. You're going to start seeing tons of these AI devices coming out this next year. And
Apple came out with one recently.
who did? Apple?
Yeah, yeah.
What did they come out with?
They call it Apple AI, of course, and they're putting on board, putting models on board so you don't have to query like an external API.
Wow. Wow.
Yeah,
And they have the heart.
So with that said, we're going to go right to the icebreaker. It looks like you guys are ready to talk some. So here's the icebreaker. In what area do you most think AI will never surpass human abilities, and why?
Oh, I
Emo
have no idea.
Emotional intelligence and empathy, creativity and original thought, ethical, moral judgment, complex social interactions, consciousness and self-awareness, adaptability and common sense. I gave you a few to choose from. All right, we're going to move on to the next topic and get started. Basically, this is lesson two for today. I'm pretty excited about this. We're going to talk about FFN, CNNs, and RNNs. And then next week, transfer learning and pre-trained models, NLP, GANs, and deploying models. So basically, I'm talking, well, what I talked about last time, I'll talk about again today just briefly. We have the ability to do what I call story pull push. And for the first time in history, we can pull content in a way we've never been able to do before. And it's kind of learning on demand. And it's pretty amazing. And so what I'm saying is before you run and create a video course or go do a video course, and those are good, they're just still wonderful to do. Go into ChatGPT and say, create me a course. And that's exactly what I did here. Give me 10 hands-on exercises. And that's exactly what I did here. And explain them to me. So you have an opportunity to pull learning and to get hands-on coding right in this interface. So it's amazing. With that said, if you want to learn more about PyTorch and you want to go to the documentation, it's pytorch.org. And I wanted to start you guys off today because we're going to start talking a little bit about the mathematics this area, I want to give you guys something to play around with called TensorFlow Playground. You guys may have been here before, but if you haven't, it gives you an opportunity to go there and actually run a neural net or play around with one. So I just put that in the chat. You guys see playground.tensor.flow, TensorFlow in your chat? So you see the TensorFlow screen. So if you click on that, I'm going to go ahead and bring that up in a browser, and then I'm going to run it with you guys. This is always fun to show, and this is TensorFlow. And this is a fun one if you're not familiar with how these things work. But you can actually you have your inputs, and then you have your hidden layers, and then you have your outputs. Typically, your outputs are connected to some type of activation function. And so you're going to go ahead and run this, and you can see it's going to see it can figure out it can actually divide between the inward blue dots and the outward orange dots, I guess. Well, you may choose something more complicated. Let's choose a more complicated scene. And so if you try to run that, hey, did it fine? That you still did it real good, and you get your output and you got your loss, and that's good. Let's do something a little bit more complicated. Yeah, there you go. That's more complicated. And when you try to do that, you just can't do it. So you're going to add some hidden layers. So I'm going to increase the number of layers here to 8, and then I'm going to add another hidden layer. We'll make that 4, and I'll add another hidden one layer. We'll make that 2. I'm going to run this and see how good this works. And so now it's starting to try to do it. Look at that. It's trying to there you go. Look at that. It's making some progress. Look at that. So it's trying to separate the orange from the blue dots. And it looks like it's making some good progress. So I got pretty lucky on choosing those hidden layers, didn't I? Not too bad. So you guys can play around with those and play around with that. It's pretty cool and fun. And once you get that idea, what I'm trying to tell you today is all just matrix multiplication. And I'm going to explain to you why it's all just matrix multiplication today. Cool. I think I got something here in the chat real quick. Let me read the chat. Dominic says, living brain cell biocomputers. Right. Thanks, Dominic, for putting that in there. I have had my eye on that. That sounds a little scary, but I appreciate you putting that in there. I wanted to go take a look at that link a little later. All right, we'll go ahead and get off of this and continue with our presentation. The neural network, sometimes people call it a perceptron, but we'll talk about modeling of a neuron. And so you have all these dendrites that would be inputs, right? And then based upon the inputs, the neuron might fire and transmit. And so the idea is that you have all these inputs, which would be a sum of WI, where WI is the individual weights for each one of these neurons. And X is an input, and then plus B would be your bias. But this is just a linear equation. This is no more than AX plus B of a straight line, but now you have a line in multi-dimensions. And so you have to think of it like that. And when you do that, you're just solving a multi-dimensional linear equation. And that's really all there is to it. And people make a lot more out of it, but that's what it is. And there's a problem with this too, because you have to understand it's linear. And so whenever you're working with a linear system over a period of time, as you're trying to if you're trying to model a nonlinear system, eventually that linear system will move away. And we see sometimes we call that hallucination. And with that said, I just kind of illustrate equation 2, and many times we'll take that z and we'll put it into an activation function. And an activation function will fire in different ways depending on what type of activation you want to do. Here's one where you're going to do a sigmoid, where you want to get back basically a 0 or a 1, right? Same thing with tan, but using -1 and 1. And there's something that became really famous and started being used in convolutional neural networks, and that's ReLU, and it worked really well. So, and it's just linear, so you don't have to do some of the equation work you had to do with these nonlinear functions. With that said, I just want to show you an example of a neural net, kind of the first part of a neural net, and how it just fits into a matrix, into like a matrix. And so right here you have your inputs, x1, x2, x3, x4. Here's your x1, x2, x3, x4. You have your weights. So you have your blue weights, and you have your green weights, and you have your orange weights. So basically this neuron connects to all the other neurons. This neuron, in a sense, this input, excuse me, connects to all the other outputs. This input connects to all the other outputs, and this input connects to all the other outputs. So everything connects to everything. And so when you multiply the two together and you add the B, which is going to be your bias, you get basically a multidimensional linear equation that you need to solve. That is really, in essence, all there is to this. Now, that's more simply said than done, right? It's always more than just all there is to it. But really, if you can keep that concept that all you're doing is multiple matrix multiplication, it will be very helpful and you won't get bogged down in so much theory. All right. With that said, we'll start with our first example, but let me ask, is there any questions so far? All right, so we will move on. So the first thing we want to do is we want to do some matrix math. And I'm gonna explain some of the math behind this. And then what I'm going to do is I'm going to show you how to prompt engineer this example. So the example we're going to prompt engineer today is the MNIST database. This is our first one. It's a feed-forward neural network. And the MNIST database, it's a modified National Institutes of Standards and Technology database, is a large database of handwritten digits that is commonly used for training various image processing systems. So we needed something like this, and it's been out here for a long time where there were numbers like a zip code, for example, and you want to read the zip code, or maybe numbers on a check. You want to read the numbers on a check. We needed something like this, and this was actually created by IBM a long time ago. And this particular set, the MNIST, is 28 by 28, which is 784 inputs. It's a 60,000 training image set, and it has 10,000 testing images, and it's a three-layer FFM. All right, with that said, the FFM that we're going to build basically is a feed-forward network. It's going to have an input layer, it's going to have hidden layers and output layers. And the FFMs are used in various applications such as classification, regression, and pattern recognition. They are foundational to more complex neural net architectures using deep learning. So that said, you'll also see feed forward weights and biases and activation functions. We've talked about that a little bit already. And here's kind of the Python code behind it. I did not write a single line of this Python code. This is all prompt engineered, and we're gonna show you how this runs. Before I do that, let me go to my Hugging Face site and put this link so you guys can see it. It is the link to all this code. All right, and I'll put this in the chat. So if you click on PyTorch, I opened up most of my programs. The first thing I did is I went into this Chat GPT 4.0, and I said, okay, I'd like to learn PyTorch. Give me a course on PyTorch with 10 hands-on exercises, because I want to make sure I'm programming, right? So it gave me these 10 hands-on exercises. And what I've been doing is going through and prompt engineering them, not writing a single line of code, just prompt engineering them. And then I've been running them in Hugging Face. So all these programs that I've been running are running in Hugging Face. And you can click on any of these. We went through these last time. Here's actually a simulation tool. We can actually put code in here and run for you. We did a TensorFlow exercise. We built a simple MVP for a scatter plot. We built a linear regression last time. We built a logistic regression system. And today we're going to build an FFM. So we looked at that using the MNIST database. And first thing you see here is the class distribution. Now, all of this was written by prompt engineering. None of this, and all these inputs, I just said, give me the inputs, and it gave me the inputs. So very smart. All right. Now, later on in today, we're going to actually reverse engineer this whole thing. And I'll show you how to just take the code and put it in and ask for a prompt to create that code. So you want to go both ways, right? So you can see you've got all your hidden layers and you've got your three hidden layers. And you got your learning rate, you got your momentum, and you got your epochs. So you can change those epochs and run this. We won't run it right yet because we got a little more theory to do, but I want to show this to you. And let me go ahead and put this link so you can go to it because it's wide open and you can actually go look at the code as well. So when you're in this particular system, all you have to do in the Hugging Face, and you all should have a Hugging Face account, is go to Files and just click on Pages because all these are different pages. And you can click on the code that you want to run. And there's your FNN. And you scroll down right here, you can see that there's your layer. And here's your first layer. And here's your three hidden layers. And here's your output layer. All right, with that said, all right, taking a look at this real quick, just the diagram, you got an input layer, a hidden layer, a hidden layer, a hidden layer, and an output layer. And once again, you can change your epochs. Now we're going to prompt engineer this together. So the first prompt is implement a multi-layer feed-forward neural network for a classification task. That is the MNIST digital classification. Use PyTorch's built-in modules and functions. That's all I say. Now I'm doing what's called an MVP, a minimal viable product. Once I build that, then I add to it, then I add to it, then I add to it. So think of yourself as a coding sculpturer. You're going to build the basic thing and then you go sculpture it into whatever you want. Now, this particular type of coding is really good for 200 lines of code. It works really well. As your code gets bigger and bigger, you're going to need to separate it and work on those pieces individually. That's just where the system is and how it works the best. So let's take this real quick and let's throw it into our into ChatGPT. Let me bring that up. And it's going to talk about the libraries it's going to import, and it's just going to go to town. And it's going to start building your layers. There you go. Oh, it's going to give me the complete code. Good. Yep, looks good. But with that said, I can't interact with it, right? Because I need to put a Streamlit interface on it. And actually, ChatGPT 4.0 does really well with Streamlit interfaces. So I'm going to come along here and take the next prompt. And let's pull that up. The next prompt is for the FFNN above. That's going to be the code above. Put a Streamlit interface on it. Move this out of the way. And what it is that I have this for the FFN above, put a Streamlit interface on it that has the appropriate inputs, sliders, and outputs. Show additional inputs or outputs that might be instructive in understanding what the FFNN is doing. So the first thing, I'm giving it full license to put all the inputs that I might need and give me all the outputs that I might be. And then also to take instructive license. And as a teacher, as soon as I say to be instructive, what I'm cueing it into that it's a teacher and it wants to build the software so students can learn it more rapidly. So I'm going to take this now and I'm going to put this in here. I'm going to run it. And then you'll have to continue to sculpt it. So if you put it into Hugging Face and it doesn't run, you just take the error and feed it back in and say, fix this error. And then eventually you'll get where you got a nice running program. Most of the time this runs the first time. Sometimes it doesn't. And I'll go back, I'll feed that error back in and I'll fix it. So now let's go pull my Hugging Face, my ChatGPT back up. Excuse me. And I'll put that prompt in. Oh, get that off and run it. And immediately what you're going to see is going to tell me what it's going to do. And you're going to, there's my Streamlit interface. It's putting my Streamlit interface on top of the program. So it's taking the program that's there and it's starting to craft it. There's my layers. Perfect. Looks great. There's my range. There's my loss function. There's my back propagation. Everything's right. Here's my feed forward. There's my title. All right. Here's my figure. You can see the figure's going to be plotted out. So it looks like it gave me everything I needed. And that's pretty much all there is to prompt engineering that. And I really didn't have to do a whole lot of that, a lot of work there. And when I pasted that in, we won't work with this one, but when I pasted that in, I got a program that looked like the one in Hugging Face. Pretty much, if you look at it and you scroll the two together, you can see they're very similar, if not the same. All right, with that said, we're going to actually run this program now. And so we're going to go to apps. We're going to go to FFN, and we're going to reduce the number of epochs. Now watch what's happening here. When I change the epochs, you notice this changes because what it's doing is randomly selecting 60 images. So this particular count right here, you can see that I got a 10 count for the number 0, but and only my lowest one would be 5. So maybe I want a different count. I can cause it to reshuffle if I want to, but I'm going to run about 3 of these and let you see the program work. Let's try it again. Let's see if we get a better shuffle. And it's going to train these and it's going to actually run them. And let's see what we get. Now, this whole class distribution, that was not something I asked for. And nor were these numbers something I asked for. But when I said make it instructive, it put this at the top so the students could see what they were working with. And it created this class distribution code. It could show the distribution of numbers. So I thought it was pretty sweet to do that. So you want to just hit train network. Now, this is a little bit slow. I actually could increase the training, and I may do that in a moment, but we'll let this run. And we're going to train it, and then once we train it, we'll be able to test it. Okay. With that said, are there any questions so far? Have you done this type of prompt engineering before?
I've been Not really. I've been using Command R plus from Cohere,
Yeah,
and they have a playground, and
yeah,
I see all the switches and stuff, and never knew how to use them. But now I'll actually make the effort and see if you've explained it.
yeah.
Say
I,
again?
I wrote 4 programs yesterday. It's like,
Oh, yeah.
you know, maybe I used to write 1 program in a week. I wrote 4
Oh,
yesterday.
yeah.
It's like,
The seeing the interface with all the sliders and stuff, like just looking at it makes me upset because I think about all the time I'd spend like just
oh
doing
yeah,
that.
oh yeah, it's time intensive. Now we got epoch 1, we got epoch 2, we got one more epoch to run, and you can see your loss is being reduced, so it's getting better. And I believe that was the final epoch. So here's it's showing your loss curve. Once again, it gave me this. I didn't necessarily ask for it, but it knew I'd need this. And then now I want to test the network. So let me test it. And it's going to run the test data net through and show me how well it did. And it gave me a 96% accuracy, and it's showing the ground truth numbers against the predicted numbers. Pretty sweet. And so let's,
Michael, can I
yeah,
ask you a question?
sure.
I know that they're using convolutional networks. Maybe you'll present something, but has anyone added a convolutional filter to this problem to get 100% using the MNIST data set?
Not to this one. My next one is a convolutional example. And it's using filters, but I haven't, what you would do, and that's a really good question. And I was actually demoing this to some people at work yesterday, and they came with some really good stuff. What it is you treat it as a minimal viable product. And so what you do, you build something and you build something else. Then what you would do is do I pronounce your name Mar?
It's fine. Yeah.
So what you do, Mar, is you would just ask it to do that. Now please add this to it and see what would add that. Matter of fact, we can do that right now. Let's try it and see what happens. We won't actually run it, but we'll ask it that question. Let's go to back to and notice I just reduced the epochs to 3. And the reason I did that, and so it didn't give me as high accuracy. The reason I did that is because I didn't want to wait forever because it runs kind of slow on Hugging Face. You can increase the processor, but you're going to pay for it. So there you go. But let's see if we can ask that same question. So I'm game. Okay. So let me bring up. So what we'd like to do? Go ahead and can you put the question in the or the
Um,
addition in the chat?
insert convolutional filters of in a number of 24 filters and use the filters in parallel with the feed-forward network. So it would be a hybrid and some maybe in parallel with the first layer of the feed-forward, and then the subsequent 2 layers will be only feed-forward.
So let me tell you a secret, okay? Uh, it loves redundancy. So let's give it some redundancy. Let's say it, you just kind of said it in a different way again. So let's go ahead and give it to me. I'll say it again. Go ahead.
Add 24 convolutional filters to operate in parallel with the first hidden layer, and the second and third layer will be just straight linear. So it's going to merge. It's going to have a convolutional layer in parallel with the feed forward layer, and then those will merge into the last 2 layers.
Well, let's see right here and see what happens.
And that's not a standard. It's not a standard way of doing it, but I'm just curious to see what it comes up with.
Me too, me as well.
We didn't mention pooling, so it's going to have to come up with that.
Well, it looks like it did because if you
Hmm.
come up here, you did see the word pool, I believe.
Yeah, that's kind of implied in the convolutional stuff.
Wow. So, I mean, I don't know if this will work or not, but this is its first stab. It's got 24 here, like you asked.
Does it add the output of the convolutional to the first feed forward? Does it merge them?
Let's ask,
I can't read your screen exactly.
let's ask the question. Does it, go ahead and continue with your question. Does it add, go ahead, ask your question again.
Does it merge the results of the convolutional filters with the first feed forward layer
Does it merge the result of the convolutional um,
filters
filters?
with the first hidden layer feed forward network FFN?
And this is what I do all the time. If it doesn't seem right, I'll ask if it did that. And if it doesn't do that, I'll go back and ask it to do that. Let's see what it says.
Oh, it volunteered to write another script.
Oh, there you go. And it does it all the time. Yeah. This is new. Chat GPT 4.0. Oh, this is new.
Can you export that chat as a public? You used to be able to export OpenAI stuff. Yeah, yeah, it's come through the chat. Let's see.
And then, and I've worked with stuff like this before, and then what you do is you just keep working on it. So if it doesn't quite give you what you want, so you run it, you get an error, just feed the error back and work with it.
Yeah, it's readable on Microsoft's browser. It's opening.
Excellent. Okay, I'm gonna continue with the presentation. Thank you so much for that input. That was great. That's exactly what I want to illustrate. All right, so we looked at those and we saw our loss curve and we actually saw our output. Very good. Next one is concurrent neural networks, and this has been around for a while, and it actually was the most successful and first commercialized neural net. It actually made money. IBM published it years ago. And what was so unique about it, if you would apply a filter to one of these images, you find out there would be unique patterns. Right? Wow, a dog would have a unique pattern, a cat would have a unique pattern, and it just was just surprising. And so we called this features, and we could actually pull several features out by doing these convolutional filters. There you go. And so let me go ahead and continue with that. These slides actually come from James Brigg, who does an amazing YouTube on this. So I'm going to put a YouTube out there for you guys to look at. And we're actually going to build some nice code here. Just by prompt engineering, we got a really nice example for you guys today. All right, so make sure you watch James Briggs' video on convolutional neural networks. So with that said, continuing with this presentation, I'll go through really quickly. Here's an example of a filter. And so you might have a certain area of the filter, and these are activation numbers. And you're going to run a filter over it, and you're going to basically come up with a scalar number. And since you're going to compress a feature into that. And then and when you do that, you'll continue to, and here's an example of the matrix multiplication that you might do. For example, if you had a 3x3 filter and you're basically walking over the entire image, you'd be multiplying these matrices and creating a scalar. You'd be reducing it. And so the output is a feature map or an activation map. And of course, there is a loss when you do compression. But it has worked really well for image classification. And that was the whole thing that we did for years was image classification. And we did, and then we got really good at it when we could look at something and tell the age of somebody. And Amazon was putting stuff out where they could actually tell if someone was happy or sad. And it was really amazing stuff. And this is what we used neural nets for. And suddenly generative transformative AI came out. And that just changed how we thought about and how we were using AI. That's pretty amazing. So with that said, you can change lots of things. You can change the matrix size. You can change the stride. And the stride is basically how many of these cubes you jump over at a time. And the more layers you have in a network, you might be pooling more layers. The more features you can get. So here's an animal. Maybe you only have 3. Maybe you have 6. You can call it a dog. Then you can actually get the breed of the dog. So it's pretty amazing the stuff you can do with this. And we'll skip over pooling is also a part of this equation, and we will not be going through all the detail. Please watch that video to do so. But basically, you see you got an image of a zebra and some portion of it where you've actually done a convolutional and pooling, and you eventually end up into a neural net, which allows you to classify. And here's your classification of horse, zebra, and dog. And with that said, what I want to do is I want to create a convolutional neural network just by prompt engineering. So that's the theory. Now let's build it. And so I'm going to use the CFAR dataset. And this was a Canadian Institute of Advanced Research. It's a collection of images that are commonly used to train machine learning and computer vision algorithms. Is one of the most widely used data sets, when you start learning this type of stuff, is 60,000 images, 32 by 32 color images in 10 different classes. The 10 different classes represent airplane, cats, cars, birds, cats, deer, dogs, frogs, horses, ships, and trucks. And there are 6,000 images for each class. Now, once again, I had no idea in a sense. Well, of course I've seen it before, but if I just created my course, right? And this appeared in my course as one of the examples to use. I look up the CFAR10 database using ChatGPT, and this is what comes out. So and since we've never been able to do this before. We spent hours and hours combing through books, watching videos, trying to come up with everything. But yet this is just giving the knowledge to you just by prompting. And you continue just to follow your face, learn this information very rapidly by creating examples and playing around with it. Once you've played around with it, you have a place to hang your hat. You're starting to ask questions. Well, how does this work and how does that work? Then go watch those video tutorials and go, oh, it all sticks. I understand what they're trying to do. And then go back and play some more, build some more stuff. So it's kind of learning on demand. And it's just amazing to do. Like I said, we've never been able to do this. What we do is we put a bunch of kids in a classroom, like 20 to 30 kids in a classroom, and we force feed them. But we don't want to force feed knowledge. We want them to pull knowledge, right? And that's the whole idea that I'm trying to preach here today. So with that said, let's look at the first prompt. And so here's my first prompt. And in my prompt, I say, all right, develop a CNN for image classification using the data set like CFAR10. Include layers such as convolutional pooling and fully connected layers. And then two, once I create that MVP, that minimum viable product, then what I'm going to say is for the CNN above, put a Streamlit interface on it that has the appropriate inputs, sliders, and outputs. So additional inputs and outputs that might be instructive and understand what the FFNN, oh, I got to say CNN, bad. CNN is doing. Okay, so bad mistake. What's so interesting about this, I'm going to get some stuff I didn't expect, and you'll see that in a moment. And what you can do is come back and ask this question like, well, what should I see? What would be the most efficient way to measure, measure if you were successful or not? So you can actually talk to this like it's a person. And so we've never been able to do that before either. So let's go ahead and take this prompt and let's throw it into ChatGPT and see what comes in. And you might want to clear your prompt. Start a new prompt, and let's go ahead and put that in. And this is totally amazing to me because, I mean, I've been doing prompt engineering since this started, and it's just getting better. There you go. There's your layers. All right. There's your back propagation. Let's see if it's bringing in. There it is. There's your data set right there. Your Centra 10. Cool. Now, with that said, we want to put a Streamlit interface on it. So that's instructive. That actually will teach us something. So let's take the second part. And immediately it's going to put a Streamlit interface on it. Which is, I mean, this is just amazing. I mean, it's all hat now, right? But it's just from my perspective, this is just amazing because you're just speaking code into existence. You go, my goodness. There you go. Same old, same old. And it's killing it. So what I'm going to do is I'm going to go ahead and take a look at the what I got when I put this code. And once again, if you run it, you get an error, feed the error in and say fix the error. And you may do a few iterations of this. And sometimes if you have a difficulty fixing the error, say re-architect it. And say you're not fixing it, so re-architect it. And then re-architect the solution. Typically that will fix the issue. So with that said, let's go to our Hugging Face and take a look at that real quick and see what we got, what actually came out. So in the PyTorch, if we bring that up, and we got about 11 minutes, so I can't belabor too much longer. And we're going to go to our CNN. Oh, there you go. Look at that. There's your image data set. Once again, put that in there. I didn't request it. And once again, gave me that classification distribution. And I got epochs here, and I'm going to bring it down really low to 2 epochs. So it runs really fast. And it's not going to be very good, but we're going to, well, let's give it 3 epochs. But, as you do more and more of them, they actually really slow down. And let's go ahead and run it, start training. All right, it's going to train away for us. And as it's training, I'm going to stop for a moment. I'm going to bring up the chat and see if you guys have any questions.
Michael, how do you get Hugging Face to run your Streamlit?
Okay, so what I do is, this is a really good question. Thank you for asking. I'm going to just, as this runs, I'm going to bring up another version of Hugging Face so we can talk about that. But when you get Hugging Face, all right, and we'll take a look at PyTorch. What I'm doing here is, this is really nice. It's a great way to set it up. Is notice I have app and I have all these applications underneath it. So when you make an application in Hugging Face, let's go there first and create that. You might go to, okay, let's go to spaces, and then you might go, hey, I want to create something. And so let's go ahead and create a space. And then you're going to go, oh, anything. Let's say test space. And then what you do, you choose Streamlit. You have Streamlit, radio, Docker, or static, which means you can put any HTML file you want in there. And I chose Streamlit. I can be public or private. For this one, I choose private, and I go create the space. So that will allow you to run your Streamlit. Okay. Now, with that said, what you want to do is, if you're doing a lot of stuff like I'm doing, you're doing prompt engineering, it's nice to set it up like this. We have an app and you have all these different menu items. Because if you go to file, what you do is you put your app on the outside. That's your program. And see, this is the description of the course. And then all the programs that you prompt engineer, you put in the folder pages. So if you go to pages and then you just say, oh, and you put one, that will be your first one. Two will be your, three will be, I just separated them in case I want to put something in between. They'll line up as the next one. It just lines them up by the next highest number. So if you click on that, that's exactly the code that I'm prompting. I just paste it here. And what it is, this is disconnected from all the other code. So I don't have to worry about trying to make sure all the code is working together, because each one is like a separate application. So this is a great, so many times I'll prompt engineering something and then I'll iterate on it, but I don't want to erase what I initially did. So I'll just go and create another page that has the new prompt, new addition to it. Okay. Did that answer your question? And so you're just pasting that Streamlit code right in there.
Saved in Hugging Face to actually a website with your code running, the Streamlit running.
Yeah.
Is there a broadcast button on the page here?
Yeah, there's a public, set it public. So if you go, yep, you set it public. I may have gotten on the wrong Hugging Face. No, it's still running. What you do is when you create that file, let's do it again. If you go to settings.
Oh, so each page can be done separate.
No, this is a whole application. Each application is done separate. This makes the whole application public.
Okay.
Also, be aware that you also can put secrets and keys in here. So if you have like
API.
yeah, absolutely. Yeah. So make sure that if you have a secret key, you put it in secrets and not variables, because you can put it in variables, but people can see that. Make sure you put your secret keys in.
And how do you know the URL of the public Streamlit app that you've just published?
Oh, it's right here. So if you go right to it, see, for example, if you look at this one, if I click on app, that's it right there.
Oh,
That's it. So if I go to my Hugging Face and take a look at it, this is a good question. Take a look at it, and these are, you click on any of these, and there's your, that's it. That's what I give. That's what I gave you guys. This is what you're seeing.
is this a free tier on Hugging Face or something else?
I'm paying for mine, but free will work the same.
Huh.
Yeah, free will work the same for you. You can get it. You get Hugging Face is free. I pay like $10 a month for it for other features, but yeah, this will work. You can do this with Hugging Face for free.
Oh.
All right, it looks like it ran, and if you scroll down, I got my loss curves, which don't look too hot. I had to run them a few more, but I also got a confusion matrix. What do you think about that? And that I thought, wow, I didn't expect that. So that's pretty cool. And we got about let's see here, 6 more minutes, so we'll run through RNNs pretty quick. But I just thought that was pretty sweet. And you can keep adding to it and working with it, but yeah, looks pretty nice. Okay, with that said, our last one is RNN. Let's hit the slides real quick. Yep, we'll click through that. RNN recurrent neural nets is kind of where all this started, right? Because what we wanted to do is we wanted to predict what's going to happen next. So in a sense, it's almost like these are inputs on different time scales, right? You can imagine if you're trying to predict the stock market. You're basically iterating. So RNNs are designed to handle sequential data where each input is independent on the previous inputs. This is achieved through network's ability to maintain a hidden state that captures information from prior inputs. Unlike feed-forward neural networks, where connections are only moved forward, RNNs have connections that loop back on themselves. these recurrent conditions allow the network to retain information over time. It's a predictor. And that's where all this happened. And once again, but if you look at this right down here, as you're moving forward in time, you can see this is the time before, this is the time now. It's still a linear equation. So F and G are, and then where F and G are activation functions. So I know I'm pretty quick. We only got a few minutes here, but we're going to go ahead and take a look at this code. But what I'm doing is something different now. I'm not going to prompt it. I'm going to take the code and ask for the prompt. So you might have some code, and this is going to be very instructive because it's going to kind of give you a whole bunch of stuff. And if you put this back in, you'll get the exact program back, but it gives you a way of thinking how the program's thinking. So let's go ahead and just go to the code, and we'll also run it. But what I want to do is get the prompt. So it's actually going to go in the reversed way. So go ahead and go here, go up to files, go to pages, and go to FFN. No, wrong one, sorry. Go to RNN, and copy that. And all you need to do is go back to ChatGPT and say, given the code, give me a prompt that would produce it. Okay. I got to make sure that I put the right thing in, right? Let's try again. I'll go ahead and clear my screen. I'll put it in brackets. So let me go back and get the code again. Do as I say and not as I do. There you go. There you go. Here's your prompt. All right, so this is pretty verbose. So I'm gonna see if I can get it to be less verbose. And it's showing me that using that prompt, it actually recreates the code. So if I put this prompt anywhere, it's going to create this exact code. So what's expensive? You know, what is the prompt? Am I gonna have learning on demand and all I have in it is a bunch of prompts? You know, is that what's expensive? So anyway, that was pretty much the demo. We will try one more thing as it cranks us out, and that's pretty did it. Can I reduce this prompt to one paragraph? And so you're seeing that it keeps memory of what you're doing, so you can just keep iterating on it. All right. Here's my paragraph. There you go. There's my prompt. And you can put that back in. I'll leave that as an exercise for you guys as you begin to prompt around. Just a few more things. I think we're not going to have time to take a look at MLV, but one of the things as you build these models out. Oh, let's run the program real quick. This was a really simple program, and this is like a predictor. And it's not and one the problem I was having with this as I wrote more RNNs, they're really heavy and they're very slow. So I wanted to write a fast one. So this is the simplest one I could think of. And so if you look at this RNN and you say, let's just write something like, hello, hello, hi, hi, hello, hello there. And then we're going to basically going to go run 100 epochs on it. And we're going to say, start with the letter H and see what you generate. What would generate next from this, from training that. So let's train that model. So it's training through it real quick. And then it's going to generate for me. And let's see what it generates. Generated, let's generate the text. Okay. Oh, Dio, 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 Dio. Oh, well. Sometimes you get lucky, sometimes you don't. I mean, the last time I did it generated the word hi. Okay, so that's how it works. And it's pretty much just an illustrative of RNNs. You'd have to basically do a lot more training and a lot more data to get something out of this. So that said, we are come to the end, our last example. And pretty much I was going to talk a little bit about ML ops, but I can leave that for next time. And it's in the slide deck. So we've hit the end of the course. I like to hit in right on time. We're at 4:31. So guys, I hope you enjoyed the presentation. I am going to hang out here for any questions that you might have. What do you think so far?
I think it's brilliant what you're doing, and it's wonderful that you're sharing the pioneering that you're doing. I've done some things similar, but not to the same scope. And I don't. My portfolio is very small, but I really appreciate what you're doing.
Thank you so much. And I really encourage you to really start hacking away because after a while it becomes natural and just reason with it. You know, what has happened is captured human reasoning. So it will reason with you. So you can reason with it and figure out things. And it works really well on queuing. So if you put kind of these partial things in there, it picks up on them and it actually queues to them. So it's pretty fascinating. I mean, I'm I'm just, I'm doing this now and it always looks so hat now, but this is really pretty amazing. Never did I think in my life I would speak code into existence. And I've always thought I'd love to write my own language. Now I don't have to do it. I can do that. Not in 15 years, but like in a month or a week. It's like